Suppose you are now 40 years old and want to receive $1 million at age 65 when you retire. You want to deposit annually in an individual retirement account that earns 6% annual interest. Additionally, you can deposit a lump sum of $90,000 now in the account. How much should you deposit each year? Well, first, the time t in years is equal to 65 minus 40, which is equal to 25, the number of years from age 40 to age 65. Also, because you want to deposit annually, we assume the interest is also compounded annually. And now before we solve the problem using the TVM solver, we need to gather the information we have in the table below and then solve for PMT, which will give the required yearly deposit. Capital N is the total number of payments. Because you are paying one time a year for 25 years, capital N is 1 times 25 or 25. I% is the annual interest rate expressed as a percentage, which is 6. PV stands for the present value, and because you are starting with a deposit of $90,000, the present value is going to be negative $90,000. We use negative here because remember, whenever paying it's negative, whenever receiving it's positive. PMT stands for the annual payment, which is what we are solving for. FV stands for future value, which is the $1 million that you want to receive. Because you want to receive $1 million, the future value is positive $1 million. PY and CY are always the same. PY stands for the number of payments per year, and CY stands for the number of compounding periods per year. In this case, they're both 1. And now we go to the TVM solver. I'm going to use the TID4. From the home screen, we press Apps, Enter, and enter the information. Capital N again is 25, enter. I% is 6, enter. Present value is negative 90,000, enter. The payment will come back to. Future value, 1 million. PY, CY are both 1. When we enter a 1 on 1, the other automatically updates. Now we go back up to PMT. So with the cursor blinking on PMT, we press alpha enter to solve for the payment. And notice how it's negative because you must pay $11,186 and approximately 31 cents each year to accumulate the $1 million at age 65. Technically, we should round up. Because if we round down, you would be just short of $1 million. If we round up, you would have slightly more than $1 million at age 65. But I'm going to go ahead and follow the normal rule of rounding to the nearest cent. So again, PMT for our table is negative 11,186.31. So to answer the question, you must deposit $11,186.31 each year to receive $1 million at age 65. I hope you found this helpful.